All right, students, welcome to what is a brief lesson on piecewise parametric equations. And so if we look here at our lesson objective, what we're attempting to do is to trace the path of a 2D shape in the coordinate plane. And we're going to be creating a set of piecewise parametric equations which describe the tracing of that 2D shape. And what we're going to be doing is using the parameter of time. And so our time parameter, and essentially what that's going to allow us to do is not only be able to look at the rate at which it's being traced, but what point we're at different points of time. Okay, so what I'm going to do is focus on example 2 and example 3, and those two will be enough for me to highlight all the key conceptual points that you need to understand, and then your assignment will be to complete the remaining examples. Like I said, nice short lesson. Okay, so the instruction here, we have to create a set of piecewise parametric equations that allow us to draw the triangle that starts at point A, travels to point B. From point B, it's then traveling to point C, and from point C, we are then traveling back to point A. Okay, so we have three variables at play here. We've got our x coordinates, our y coordinates, and then we have our time parameter as well. Okay, so first things first, we want to look at how we get from point A to B. And so we've got both magnitude and direction. And so what we're talking about, of course, is a vector. And so what I'm going to do is I'm going to call it vector AB, but that's actually going to be used, well, I could use that for the entire equation. And so I'm using that to represent the equation for the drawing of side AB. And so we've got vector AB over here. We know that we are starting at point A, which means my position vector is going to be the point minus 2, 4. And then I'm going to introduce my time parameter, which allows me to know where along the vector I am. And over here, we are going to put in our direction vector or velocity vector, and that actually is going to be vector AB, but there's a couple of little modifications that we need. Okay, so first of all, we need to take into account that to move from A to B takes 2 seconds. Okay, so 2 seconds to draw each side of the triangle. And so what we need is the horizontal and vertical components that get us from A to B. So I need to go over a certain distance, and in this case, down a certain distance. Algebraically, the way that we could do that is, of course, to take B's coordinates and subtract the corresponding coordinate for A. And so 3 minus 2 gives us a distance traveled of 5, or of course, given that we have a graph, we could very easily just count the blocks. Okay, similarly, I'm saying minus 1, and I'm subtracting 4, and so pretty much 5 to the right and 5 down is going to get me from point A to point B in the direction A to B. And now the next thing I need to really take into account is the fact that that has taken 2 seconds. And my parametric equation with the time parameter t is really describing the motion per second. And so the way that I'm going to account for that is simply to say if the total movement is 5 right and 5 down over 2 seconds, then that must mean it's 2.5 to the right and 2.5 down per second. Okay, and lastly, as with any set of piecewise functions, we need to define our domain. Our variable in this case for our domain is, of course, time. Time starts at 0. At 0, of course, we would be at point A, our position vector minus 2, 4. And then we're going to go up to, and in this case, not including 2 seconds. And I'm going to talk a little bit about the including, not including at the end of the example. And so bear with me on that one. Just put a pin in that for now. Okay, so that's our first of three different equations to represent, of course, the drawing of the three different sides. So A to B, we're now going B to C. Of course, that is also taking 2 seconds. And so I'm going to represent that over here to draw side BC of our triangle. Our starting point for side BC is, of course, B's coordinates, 3 minus 1. And now the first of the details that we need to pay attention to. And the first of the details that we need to pay attention to is that my time parameter now changes to t minus 2, so that we realize that after 2 seconds I've drawn this, and in fact, as I start the drawing of side BC, I'm now into the 3rd second, right? And so I'm doing t minus 2, and then I need to figure out what my direction vector is going to be, keeping in mind that we want that as a per second velocity or magnitude, velocity or direction vector. Okay, so same thing. How do I get from B to C? We can break that down into the X movement and the Y movement. And so I'm going 3 blocks down. Of course, that's my vertical. And I'm going from 3 to minus 3, which is going to be a total of 6 blocks to the left. And then I must remember also to divide that by 2. So the 3 blocks down and the 6 blocks to the left is in fact what happens over 2 seconds. And so per second, I am moving 3 blocks to the left per second. So 3 blocks to the left after 1 second, as well as 1.5 blocks down. And then in the second second, I'm moving the other 3 blocks to the left and 1.5 blocks down. Okay, and then we need to, of course, define our time parameter for the drawing of side BC. And so that is, of course, going to pick up where we left off, starting at time 2, including. And so what you'll notice is what I'm doing here is not including 2 here, but including 2 here. So I don't want any overlap in my domain. And there is a little bit of flexibility here. If you had included 2 in the first equation, then you would have not included in the second, and that's okay. That would be a correct answer as well. And then, of course, I'm going to go to my upper bound. It's taken 2 seconds, and so I'm arriving at 4 seconds. I'm getting infinitely close just before I get to 4 seconds to point C. All right, and so the third one, I'm now at point C, so I now need vector CA. Coordinates of point C are minus 3, minus 4. That's the position vector for the start of the side of the triangle CA, the line segment CA. Once again, watch out in your time parameter. We need to take into account that the drawing of side CA doesn't begin until after the 4th second. So we have T minus 4. Once again, we need to take into account that our X shift and our Y shift to get from C to A is going to happen over a time period of 2 seconds once again. And so in terms of X movement, we have got minus 3 minus minus 2, minus 3 plus 2, of course, which gives us minus, beg your pardon, other way around, minus 2 minus minus 3 is minus 2 plus 3, which gives us 1, because of course we're going vector CA, which means we must do A's coordinates minus C's coordinates, my apologies. And so, of course, graphically, that's obvious. We're going 1 unit to the right, but that 1 unit to the right is for 2 seconds. And so that means that we are doing 0.5 blocks to the right per second. And then we are going from minus 4 up to 4. So it's a total of 8 blocks up, which means 4 of those blocks are happening per second. And last but not least, now we need to complete our domain. time parameter domain. And so including for this time, because I excluded it last time, and I don't want any overlap, but I also don't want any discontinuities or breaks in the graph. And that is going to go up to, and this time, including 6. And I'm going to spend a few minutes explaining that now. Okay, so that's what we're going to do. What I'm going to do now is just spend a few moments clarifying why it is I've done what I've done with the time domain. Okay, and so like I mentioned at the beginning, we're really interested in modeling the x coordinate relative to time and the y coordinate relative to time. And so we do have this additional parameter of time, which is not necessarily obvious from our graph. And so I'm going to use the following plot. So I'm just going to sketch really quickly a coordinate grid. And what I'm going to plot is the position of the x coordinate relative to time. And I'm just going to use that to help you to understand why I've done what I've done with the including and not including of the different pieces of the time domain for your parametric equations. Okay, and so our starting point obviously occurs at time equals 0, and at time equals 0, our x coordinate is at -2. So we have an x coordinate of -2, and that is occurring at time 0. And so I'm just going to put in a few markings here. So 6 markings because we've got a total of 6 seconds. And then I'm going to just switch colors here. And so in terms of the x value at time equals 0, which is along the y-axis, which in this case, of course, is our x-axis, our vertical axis, I'm starting at -2. By the time I arrive at t equals 2, I've arrived at an x-coordinate of 3. And so my x-coordinate of 3 is over here, and that is going to correspond to the time value of 2. By the time I reach my time value of 4, I have gotten infinitely close to, based on the way that I've set it up, I've gotten infinitely close to reaching the x value of -3. And of course, when I'm at the time value of 4, I'm at the x value of -3. And so for time equals 4, I've then got an x value of -3. Okay. And last but not least, when I complete the drawing of my triangle, I'm at time 6, and my x-coordinate is, of course, back to where we started if you consider the coordinate plane, and that is, of course, back at -2. And so at time 6, I'm back at -2. And now what I'm going to do is just join each of those. And what you can see is this is the graph that shows how the x-coordinates change with respect to time. Okay, and so what's important here to highlight is what I mentioned before. I could have had this first equation with a domain of 0 less than or equal to t less than or equal to 2, as long as I then didn't include it here. So we don't want our time domain to have any overlap, first of all. And then the second important point is, of course, that I want to include t equals 6. If you look at this graph over here, you could make the argument that I included the point in the first one, and so I don't need to include it in the second one. But of course, if you look at the graph, the linear graph that relates x to time, we do, of course, want to include it. It's a different point, t equals 6 and x equals -2, to t equals 0 and x equals -2, and that's the reason we need to include both of those points. Okay, hopefully that's reasonably clear. What I'm going to do now is try to be as efficient as possible. And so I'm just going to do a quick copy of my parametric equations from this example. And we're going to move down to example 3. And so what you're going to see for example 3 is that it is the same question. And this time what is changing is we have 2 seconds to draw side AB. It takes 4 seconds to draw side BC, and it takes 3 seconds to draw the last side, side CA. And so I'm going to really quickly just put in those markings that we had from before. And so we were 5 to the right and 5 down to go from A to B, to go from B to C. We were going from -1 to -4, and so we were 3 down in that particular case and 6 to the left. And lastly, we went a total of 8 units up and 1 unit to the right for the last one. And really, I've drawn those in. It's probably more working than I need to show, but I just want you to explicitly make the connection that since we've altered the amount of time taken to draw the side, the impact here is going to be twofold. And so it's really important, well, I suppose you could argue threefold really. It's definitely going to affect our direction vectors if we've altered the time, but that of course is then going to have a knock-on effect to our domains, because we're taking a different amount of time to draw the side, and therefore our domains have to change. Okay, and so what I'm going to do in here is I'm going to go in and delete that, and I'm going to go in and delete those, and then we'll just figure out some of the other details as we're going. And so don't worry too much about what I've done there. I'm just trying to be a little bit efficient, and hopefully some of the erasing that I just did makes sense. And if not, I'm going to explain that now. Okay, so I've left the drawing of side AB the same because the time didn't change, and so the equation has not changed at all. We now have to consider what happens with the drawing of side BC. So we still start at the coordinates of point B, which is 3 minus 1. Our time parameter over here is still t minus 2 because the drawing of the first side took 2 seconds. But what's changing now is that we're taking 4 seconds to go 3 down, and 4 seconds, of course, to go 3 down and 6 to the left. And so we are now going to need to change to -6/4, which of course we could simplify. So we're doing 1.5 blocks to the left per second for side BC. And similarly, we are doing -3/4. We're doing 3/4 of a block down per second for the drawing of side BC. And of course, the second impact on this is that since it's taking 4 seconds to draw this side, my domain now changes to starting the drawing of side BC at 2 seconds and finishing at time getting infinitely close to 6 seconds. Okay, and so a very similar approach is going to be needed for the drawing of CA. We start the drawing of CA now only after 6 seconds, entering into the 7th second. And so I have to, of course, change that to t minus 6. Similarly, 8 units up and 1 unit to the right is taking 3 seconds. And so I must be doing 1/3 of a block to the right per second and 8/3 of a block up per second. And last but not least, I just need to adjust my domain. And so I'm starting the drawing of side CA at 6 seconds inclusive, and that is taking 3 seconds, which means I'm finishing at time 9 seconds, total of 9 seconds to draw triangle ABC. Okay, and so as mentioned, the examples that I have not done, you should use as your assignment questions, and hopefully that's clear.